between the parents and the children, there's a correlation. If the parents, that is to say the diameter of the piece in the parent is larger than the average, then the size of the piece in the children is larger than the average. That's a positive correlation. You look into correlations if there is some sort of influence in terms of cause and effect, which is tricky. X and Y are correlated here. What does that mean in terms of cause and effect? There are several possibilities here. The simplest one being X influences Y. The size, in this case the diameter, of the parent piece influences the size of the children, which is not entirely unplausible. But equally well, X could be influenced by Y, which could not be distinguished from the data alone. It would look strange, however, in this case, if the size of the children influenced the size of the parents, but it's not always that obvious. In this case, however, you can easily discard this sort of influence. The typical situation, however, is a third one, namely that the two quantities we are looking at have a common factor between them, which is the official term. In this case, the genes, that obviously in the parents' generation have a strong influence, and in the child generation have a smaller influence. I should be saying the genes of the parents. They exert a smaller influence on the child generation. They seem to be washed out. That's the typical situation. There is a correlation because there is a common factor among the quantities. The correlation coefficient, the next notion, tells you how strong that influence is. Correctly speaking, the Pearson correlation coefficient if my data cloud looks like that, a positive correlation, then the correlation coefficient is larger than 0. Maximally, at best, the data are on a line, then the correlation coefficient becomes 1, which means the linear model is perfect. If this line has a positive slope, then the correlation coefficient is negative. X increases, Y decreases. Then the correlation coefficient is negative. At best, when the data form a perfect line, it becomes -1. If the data are purely random, imagine a dice is the number you get by throwing the dice once. Y is you throw the dice again, you get numbers between 1 and 6, and then you draw the data points. That's a highly scattered field, a nice cloud. In that case, the correlation coefficient is 0. There is no correlation. Surprisingly, and that's something to get used to, this can happen. The data fit perfectly on a parabola. If you know x, you can exactly compute without any randomness. Absurdly, in this situation too, the correlation is 0. That's due to the linear model breaking down. The correlation coefficient measures how well the linear model fits. Do you find a line? How well is the approximation by the line? And in this case, bad luck. Even though there is no randomness in this relation. And that definitely seems to be cause and effect. The correlation coefficient is 0. Related to this, how sure can you be? If your experiment tells you that the correlation coefficient is not equal to 0, how sure can you be that there actually is a correlation? That there's some sort of cause and effect in one of those 3 ways? In how far does the correlation coefficient really tell me that something of that sort happens? That's a tricky topic on itself, which is often ignored in school. That would take me half an hour. If you see, for instance, that the data cloud fits nicely to a line, that the regression line fits well, for instance that the correlation coefficient R equals 0.9, a good approximation. What does that mean in terms of cause and effect? Is there some cause? That's tricky to say. What you look into is the probability of this happening by chance. Imagine you only have 3 points. Then those 3 points could easily lie on a straight line by chance. If you have many more points, then it's much harder to have this by chance. So the number of points seems to be vital to determine how significant this result is, how reliable it is. Typically you do something that's called student's t-test, which defines a criterion. What the probability is that my data are by chance on a line, and if that probability is large, then you could hardly say that there's cause and effect.